We'll continue our unit on circles as we talk about how to find the area of a circle and how to find the area of a sector of a circle. A sector of a circle would be, as we could think of it, as like a pie piece of the pie um, in regards to the circle. So as we take a look at in a circle, think of that pie as we slice it up, or the pizza. If we take all the pizza pieces or the pie pieces, whatever you're hungry for, and we lay them side by side, what kind of shape seems to appear? It seems that we get a parallelogram, and the more pieces you can imagine as we cut them closer and closer together, the closer it would get to that parallelogram. So as we think of the formula for the parallelogram, area equals base times height, that's how we find the area of a circle. As we find the base of all the pie pieces laid together times the height. And the height, as we think of it, is what? You got it, the radius. And as we lay all those together, what do we get as well? We're going to get that circumference. So as we get the area of a circle, it's going to be pi times the square of the radius, because the height is really the radius, and the base is going to be the circumference, which is 2 pi r. But you're wondering, well, where do we get the formula pi times r times r? Where's this? How do we get rid of that 2? Well, we have to divide it by 2 because, as you see, we lay those pi pieces out. We only get half the circumference. So area of a circle equals radius times half circumference, better known as pi r squared, as we visualize it here. So let's take a look and calculate the areas of these figures. So if the radius is 2.5, our area is going to be pi r squared. So we take pi times radius squared. Radius in this case is 2.5, so we square 2.5 and then multiply that by pi. So we take 2.5 and square it, 6.25 I believe, yep. So it's exactly 6.25 pi centimeters squared, or if we want to approximate that, 6.25 times pi is about 19.63 centimeters squared. And we can do the same thing if we know the diameter. Let's say the diameter of the CD is 113, or actually, we know the area. We want to find the diameter. So we take our formula and just plug in what we know. So we know the area is 113.1, and we multiply that, or it equals pi times radius squared. So in order to get r by itself, divide both sides by pi, and we'll have to approximate here. So 113.1 divided by pi gives us about 36. So r squared is about 36, which means take the square root. R is 6. But we want to find diameter. Diameter we know is twice the radius, so diameter would be about 12 centimeters. Okay, so we know how to get the area when we're given the radius or diameter. We know how to go backwards also if we're given the area to go back and get the radius or diameter. So let's talk about a sector of a circle. Sector, as is defined above, is the region bounded by 2 radii of a circle and the intercepted arc. I talked about that a little bit last lesson. We talked about how to find the arc length. So this would be the sector, this region right here, surrounded by the 2 radii in this intercepted arc. So sector APB, kind of label it like we label triangles. It's bounded by AP and BP, those 2 radii, and then arc AB. So how do we find that? Well, you can probably guess how we'd figure that out. Well, I think if I calculate the whole area, the whole pi, and then multiply it by the ratio that we have, or the fraction percentage that we have, that'll give us our sector area. So we've got the formula listed right here a couple ways, but just think of it this way. To find the area of the sector, I take whatever the arc is divided by 360, because that'll give us our portion of the pi, times pi r squared, because that's the area of the circle. So in this case, we got the arc is 70 degrees, because that's what our central angle is. So the area will be equal to 70 out of 360 multiplied by pi r squared. And in this case, radius is 8, so times 8 squared. Okay, so take a moment to look at that formula, make sure that makes sense, and then we'll simplify it down. So 70 out of 360 be 70 out of 36 times 64 pi. Now we can simplify that down, so I can divide, let's see, can I divide 64 by 6? No. So 64 times 7 gives me 448. So 448 pi out of 36. And see if we can divide 448 by 36. It doesn't divide evenly, but we can divide them both by 4. 448 divided by 4 gives us 112 pi over 9. Looks like they're both divisible by 3. So 112 divided by 3. Oops, I was wrong. So 112 pi over 9 be the exact, but sometimes we want the approximation, so we can multiply by 3.14. So 112 times 3.14 divided by 9 gives us approximately 39.08. Let's see what our unit is. We don't have any units, so units squared. Okay, so either of these would be valid. So remember, to find this sector, just find the portion of the pi and multiply by the area of that circle. So why don't you calculate the radius of this one, or actually we want to find the area of the circle, circle B. See if you can calculate the total area of the circle if we know the area of the sector. This red sector TVU is 35 meters squared. We know this is 40 degrees for central angle TVU. So see if you can use that information to then calculate the total area of the circle. So why don't you pause the video and restart it when you're ready to see an explanation. Okay, so there's two ways that I found to solve it. Maybe you found a different way. First of all, I just took the sector formula and I plugged in what I knew. So I knew the area was 35, and that equaled the ratio that I had, 40 out of 360, times pi r squared. I simplified this down and got pi r squared over 9 equals 35, multiplied both sides by 9. Got 315 equals pi r squared, which I could have stopped there if I would have recognized that pi r squared is the area of the circle. So I would have known that, oh, that's 315 is the area of the circle. But I kept going to show you how to find the radius then as well. So I divided by pi to get r squared, took the square root to get 10.02 is approximately r. Plug that back into pi r squared, area of the circle, and got the exact and the approximated values. Another way I figured was setting up a proportion. You like proportions. So I could say, well, the area of the sector, and compare that to the full circle. So if the sector is 40 degrees, whereas the circle is 360 degrees, I can then compare their areas. The area of the sector is 35, the area of the circle would be proportional. So cross products, 40x equals 35 times 360. Solve, I get x equals 315. So there you have it, a couple ways to find that. Like I said, area of a circle should be familiar to you from your grade school days, pi r squared, but maybe you didn't know where we get that formula. So hopefully you understand that now. And then we also apply that to the sectors. So you got some time to do some practice in class, and I'll answer any questions you might have.